Hello everyone, welcome to this session. In this session, we will design something called as flash ADC. Now in this circuit, you can able to see we have designed a 2-bit flash ADC. For designing 2-bit flash ADC, we require some components. So initially if you can see over here, we have required something called as resistor ladder. For designing this resistor ladder, we have used a resistor value of 1 kilo ohm. As you can see, we have 4 resistors with us for designing this resistor ladder. Then we require to provide some analog input to your flash ADC. Then for that we will require one potentiometer. As you can see, we are having one potentiometer with us. Then we require OP-Amps. For that we are using IC LM324. Then we require 8:3 priority encoder. So for that we are using IC 74148. And to see the outputs we require 2 LEDs and 2 current limiting resistors. And to build this circuit, we require one breadboard and some connecting wires. So initially, we will just connect all the power rails of this breadboard. Okay, so I will just connect the plus VCC from this side to the plus VCC from this side. So the plus rail of this side of breadboard is connected to the plus side of this breadboard. Same we have to do with ground, which is negative terminal on this breadboard. Okay, so we will just connect negative to negative. As you know, these 5 blocks 1, 2, 3, 4 and 5, these are interconnected. Okay, but from this center terminal, these two are not connected to each other. Okay, so likewise in this, on this breadboard, 1, 2, 3, 4, 5 are connected to this side, whereas these 5 are connected to each other. So now we have to connect this power rails to each other. So as you can see, I'll just connect one power rails plus VCC through one jumper wire and ground to the ground using this jumper wire. Same with this side, we can just connect this plus VCC to this plus VCC and ground to ground. Now with the help of this connection, we can able to get power from all the sides of your breadboards. So I'll just connect this one. Okay, now we will start with this resistor ladder. So for that we require 4 resistors with the value of 1 kilo ohm. Okay, so we will just start with this one. So this is the first resistor that we have connected over here. Okay, then which is R12. Okay, R12 is connected in between plus VCC, which is plus 5 volt, and which is other end is connected to the R13 with the value of 1 kilo ohm. So I will just connect R13 over here. So R13 with the value of 1 kilo ohm. Now I need to connect R14 with the value of 1 kilo ohm. So I'll just connect this R14 over here in between R13 and R15. Now one end of R15 is connected to the ground and one end is connected to the R14. So I will just connect this R15 over here. So as you can see, we have connected this resistor ladder over here, which is R12, R13, R14 and R15. So R12, the one end of R12 is connected to the plus VCC, other end is connected to the R13 over here. So this is connected. Then one end of R13 is connected to the R14, and the R14 is connected to R15, and R15 of one end is connected to the your ground. So now you need to connect these OP-Amps. For that we are using IC LM324. So we will just add this IC onto this breadboard. Okay, so as you can see, we will just use this IC LM324. Okay, now as you can see in this schematic over here, one end of R12 and R13 is connected to the pin number 3 of IC LM324. Okay, so this is R12, this is R13. So in between this one is connected to the pin number 3 of this OP-Amp. So we will just connect that. So we will just see this is R13 and R12. Okay, and this is connected to pin number 3. Now next is we have to connect this end of R13 and R14 to the pin number 5. So we will just connect that with this over here. So this in between over here. So this is just okay. So this is R5 and this is the point between R13 and R14. Okay, now this is connected over here, which is pin number 5 of LM324. Now we have to connect one end of R14 and R15 to the pin number 10. So this is pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the third one from this side to this side. So we'll just connect this pin number 10 of OP-Amp to your resistor in between, which is so now we have connected all the references voltage to your OP-Amp. Now we have to connect this pin number 2, 6 and 9 to each other. So we will connect pin number 2 and pin number 6 to each other. So this is pin number 6 and this is pin number 2. So we will just connect it to each other. So these are shorted to each other. So I'll just connect it. So we have connected pin number 2 and pin number 6 to each other. Now we have to connect pin number 6 and pin number 9. So for that again we require one connecting wire. So I'll just connect this pin number 6 to pin number 9. So I'll just connected this pin number 6 to pin number 9 over here. Now we have connected this resistor ladder as well as we have connected these 3 pins to each other. Now what we can do is we will just add one potentiometer over here. So I will just add this potentiometer over here. Okay, so for connecting this potentiometer, one end of this potentiometer is connected to the plus VCC. So I will just connect this to the plus VCC. Okay, and one end is to the ground. So I will just connect this to this ground. So this is connected to the ground, and this is connected to the plus VCC. So one end of your resistor potentiometer is connected to the ground, whereas other end is connected to the plus VCC also. So likewise this, whereas the center terminal is connected to the pin number 9, or pin number 9, pin number 2 and pin number 6. So I will just connect this to pin number 9 so that it will be connected to the pin number 2 as well as pin number 6. Why? Because we have connected pin number 2 to the pin number 6 and pin number 6 to the pin number 9. Okay, so this way we can design the initial or the first part of this circuit. So now we have connected this resistor ladder, we have connected this op-amps. Okay, the inputs of this op-amps like 2, 6 and 9. Okay, and we have connected it to the potentiometer. Now we need to connect the outputs of this op-amps to this 8:3 priority encoder. So I will just add this IC onto this breadboard. So I will just add this IC over here. Now we will connect the outputs of these op-amps to this 8:3 priority encoder. So as per this circuit diagram, we have to connect the output pin of this op-amp, which is pin number 8, to the pin number of 8:3 priority encoder, which is pin number 11. So I'll just connect that one. So pin number 8 is connected to the pin number 11 like this. Now we have to connect the next output of op-amp, which is pin number 7, to pin number 12 of 8:3 priority encoder. So I'll just connect pin number 12 to the pin number 7 of IC LM324. And the last one is the output of comparator C3, which is pin number 1 to the pin number 13. So I'll just connect this one. So pin number 13 is connected to the pin number 1 of IC LM324. Now we can connect these 4 pins, pin number 1, 2, 3 and 4, to the plus VCC with some connector. So I'll just connect that. So pin number 1 is connected to plus VCC like this. Then pin number 2 is connected to plus VCC with this jumper wire, and pin number 3 like this. Okay, so this way you can connect pin number 1, 2, 3. Now pin number 4 is again connected to the plus VCC. Okay, now we have to connect pin number 5, which is the input enable. Okay, so which is to the ground. So pin number 5 is connected to the ground. So just connect this to the ground. Now we have to provide the power supply to this ETS-to-3 priority encoder. So for power supply, we have to connect pin number 8 to the ground, whereas pin number 16 to the plus VCC. So I will just connect pin number 8 of this IC to the ground, likewise this, and pin number 16 to the plus VCC. So this is pin number 16 to the plus VCC. And we need to connect the pin number 10, which is the input 0 of ADC-to-3 priority encoder, to the ground. So I'll just connect this pin number 10 to the ground. Now after this we have to connect these two LEDs. So pin number 9 and pin number 7. So I will just connect the S0 first, which is pin number 9 of IC 74148. So I will just connect this way. So I connected this LED over here, and I am going to connect one current limiting resistor of a value of 270 ohm. Okay, so likewise this, which is connected to the plus 5 volt. Same with S1. So as I am going to connect this S1 to the pin number 7. So I'll just connect this LED over here, and the LED is again connected to the plus VCC through a current limiting resistor. Now we will connect a plus VCC supply, which is plus 5 volt, with the use of one power supply. So I will just connect a power supply over here. So this is plus 5 volt, and this is ground. And this supply is connected over here. So this is the red wire is plus VCC. So I will just connect over here, and this one is your ground. So now we will turn on the power supply, and we will change the input voltage with this potentiometer, and you can able to see we will get two different states of this flash ADC. So as I just change the input voltage of this potentiometer, you can able to see we will get states, binary states at the output. So this is the S0, which is LSB. So if you want to check the input voltage that we have provided to this ADC, you will just see with the help of one digital multimeter. So at which voltage we are getting changes. So it means that if we provide some analog input voltage, at which point we are detecting different signals. So that's why I just make one connection over here. So as you can see, the voltage is 1.346. So again, If I change a bit more, you can able to see the change in other LED. So at this point we are getting a second signal which is at 3.066. Okay, and again if I change this, you will get third change, which is at 4 volts. So if you want to accurately find out what are the voltages, you'll just again go through the first steps. So I made the input voltage as 0.001. So as I slowly increase the voltage, you can able to see we will get a output state from 00 to 01. So I'll just change the input voltage slowly a little bit. So now it is 600 millivolts, 700 millivolt, 800 millivolt, and 1.185 volts. Okay, so at this time you are getting this first state. Now if I again increase this input voltage, so you will get 10. So now we are having at 01, so you will get over here which is 10, which is as 3 volt. Now again if I increase the voltage, you will get two steps which is at 4 volt. So likewise, you can perform a 2-bit flash ADC. Thank you.